Okay, so this is another question from the Calculus and Vectors Nelson textbook. This is page 83, question number 17, where it says to determine the equations of the tangents to the curve y equals 2x squared plus 3 that will pass through the following point, which is 2, 3. In this question, we're going to end up with two different equation of tangents, which is going to touch the curve y equals 2x squared plus 3, and it is also going to pass through the following point 2, 3. Right now we should see what happens when we plug in x equals 2 into the equation that's given to us. We can rewrite this in terms of function notation. F of x is equal to 2x squared plus 3. I can now go ahead and say f at 2 is going to equal 2 times 2 squared plus 3. This gives me 11, which is not equal to 3. So we need to make sure that the equation of the tangents will pass through 3. We can go ahead and try to find the derivative now. The derivative turns out to be 4x. And we also know that the derivative is equal to our slope, m. We also know that the slope is equal to y2 minus y1 over x2 minus x1. Right now we're told the point 2, 3. We can consider that as our first point. But what about our second point? Well, our second point, if we look into our equation given to us, x is the independent variable. So x will be x. And then y2 is going to be the equation itself, 2x squared plus 3, because it depends on whatever you plug in for x. We can now say that m is equal to y2 minus y1 over x2 minus x1, and now plugging in all these values, we can plug in the derivative for m, 4x, equal to 2x squared plus 3 minus 3 all over x minus 2. Now we get 4x is equal to 2x squared over x minus 2. I can now go ahead and cross multiply. I get 4x multiplied by x minus 2 is equal to 2x squared. Expanding this, we get 4x squared minus 8x is equal to 2x squared. I can now bring over the 2x squared over to the left side. This will give me 2x squared minus 8x is equal to 0. I can now common factor out a 2x. By doing this, I'm going to get 2x multiplied by x minus 4 is equal to 0. Solving for my 2x values now, I'm going to get 2x is equal to 0. And solving for x, I get x is equal to 0. The other part, x minus 4 is equal to 0, and x is equal to 4. I can now use these x values to figure out what my slope is going to be at those x points. I can say m at 0, which is the same thing as saying the derivative at 0, which will be equal to 4 times 0, which is equal to 0. Therefore, your first slope is equal to 0. Your second slope is when x is equal to 4. Therefore, you can say m at 4, which is equal to the derivative at 4, which is 4 multiplied by 4, which is equal to 16. Therefore, your second slope is equal to 16. Now, the question did not specify what type of equation it wants, so we can just put this in point-slope form. Point-slope form is in the form of y minus y1, which is equal to m multiplied by x minus x1. For equation number 1, we know that our y value is given to us as 3. So we can say y minus 3 is equal to our slope, which is 0, multiplied by x minus x1. x1 is given to us as x equals 2. This will give us y minus 3 is equal to 0. And we can bring the 3 over to the other side and just say y equals 3. This is your first equation. Our equation number 2 will be y minus 3 is equal to the second slope, which will be 16, multiplied by x minus 2. Now, graphing all of this on Desmos, we see that the red is the equation that was given to us. That's the equation of the curve. 2, 3 is the point. And then our purple is one of our equation of tangents, and the black is the other tangent equation. And we can see that they both intersect and pass through the point 2, 3, while being tangents to y equals 2x squared plus 3.